Chris Otter, a software development engineer working at Safaricom, and I'm also a cloud and infrastructure automation engineer. So welcome to AWS Community Day Kenya 2024. My talk will be on how we can leverage AWS IAM roles for secure GitOps. So let's dive right in. So how do you get your machine users, for instance, CI servers, to authenticate to AWS API servers without storing any secrets in plain text? And we are going to look at two examples. So the first one being Jenkins as a CI server running on an EC2 instance. And we're also going to take a look at GitHub Actions as a CI server with OIDC. So let's take a look at the first. One common anti-pattern is to use long-term access keys for your machine identities when you have the option to use temporary credentials. One of the recommendations that you'll find in the AWS Well Architected framework, the tool itself, is that all AWS API and CLI requests should use temporary security credentials. And you should also remember that anytime you federate to AWS or assume an IAM role, temporary credentials are generated for you. So how can we make good use of the automatic generation of short-lived credentials with IAM roles so that we shy away from using long-term credentials, which pose a risk, especially when they're exposed to attackers. So on that note, let's look at how we can create an IAM role for an EC2 instance running Jenkins to run your Terraform code. So if you take a look at the diagram, we have Jenkins that runs on top of an EC2 instance, and we've assigned it an IAM role. So we're going to look at two types of roles. The first being the service type role, and we're also going to look at the web identity role. So for Jenkins, the type of role that we are going to assign our EC2 instance is the service type role. And how that works is, like for most IAM roles, two components make up a role. So the first is the trust policy that establishes trust between your AWS resources and a principal. This could be a user. A user in this case could be a human user or machine user. So for our case, it's the latter. And the other component for an IAM role are the permissions policy that give privileges to access specific resources on your AWS account. So let's take a look at what's on the left of the diagram. So for anyone running Terraform, you'll be storing your Terraform state either on your default local backend, but in our case, we are not going for that. Instead, we'll be storing our Terraform state on Amazon S3, and that will form part of the resources to which we will grant our CI server access. So there's the Amazon S3. The other resource is DynamoDB that we're going to use for state locking so that we avoid scenarios where we have two or more team members pushing the same infrastructure code at the same time. Two or more team members trying to write to the Terraform state concurrently, leading to cases where we have overrides. So to prevent that, we're going to use state locking, and the resource to help us with that is DynamoDB. So we'll take a further look to see how we can be able to strictly give access only to the resources that we'll be using and no additional resources. So what are the steps involved to mimic that workflow? So first off, you define an assume role policy that establishes trust between your CI server, in this case Jenkins, running on top of EC2. Once you're done creating the assume role policy, then you'll head over to create an IAM role. Once that is done, you'll define an IAM policy for permission that should be granted to your CI server. Next is to attach the IAM policy to your IAM role and create an instance profile after that. And the last step for you will be to attach the instance profile to your EC2 instance. So let's take a deeper look into those steps. So first off, how do you define an assume role policy in Terraform? So Terraform provides a data source to help you create a trust policy for IAM roles that you create. So as you can see in our case, we have a trust policy that we're creating for our example role. And just to mention that under the hood, temporary credentials are powered by the Amazon security tokening service that gives you the rotation capability so that you are able to use credentials that are short-lived and rotated within a given duration. So you can see that the type of role we want to assume as a service, and our identifier points to an EC2 instance. So this is the EC2 instance that runs our Jenkins server. So next up is to create the role itself. So Terraform provides you with a resource to do so. And as you can see, the role policy to assume is the one that we just defined earlier, that we're referencing on this parameter. Next is to grant specific permissions. But in our case, we want to give administrative privileges so that our CI server, that is Jenkins, is able to perform all operations on our EC2 instance or instances. So that will include, as you'll see later, auto-scaling, elastic load balancing, and related operations. So once done with us granting the privileges, then you go ahead and attach the policy permissions to your role. And to help us with that, we also have a resource provided by Terraform, whereby you can attach the role and the policies granting permissions to your role. Something to mention about the instance profile is that this serves as the container for your role, so that anytime your instance is launched, then it automatically assumes that given role. So that's the role of the instance profile. And to enable that, you'll have to pass that instance profile among the arguments or parameter values to your instance. So those are the steps to help you create a role, assigning it specific privileges strictly to the resources you want it to access. So let's head over to how GitHub Actions work And in the last discussion, we looked at the service IAM role type. So here we are going to look at the web identity role type. And this applies for federated identifiers or identities, outside AWS. And GitHub Actions is the example we're going to see here. So if you take a look at the diagram, the simple architecture that we have here, we have a user who creates, a pull request to a master branch. That could also be a push to a GitHub repository that hosts your Terraform code. And that event will trigger your GitHub Actions to either do a Terraform apply, plan, delete. So how do we ensure that we've successfully authenticated to AWS and that we have fine-grained access to the minimum resources that we need in order for us to achieve least access privilege for our CI server? So to help us with that, I will more or less follow the same approach, with the only difference being that first of all, we'll have to create an identity provider. AWS as a provider supports OpenID Connect, and that's what we're going to create to help us successfully authenticate GitHub Actions so that it's able to apply the Terraform changes to the resources on our AWS account. So that's the first thing that you're going to do. Once you've created the identity provider, then next up is to create a trust policy in the same way we did for a Jenkins running on EC2. The only difference is that this trust policy, instead of being of the type service, it will be of the type federated, because this is a federated authentication. Then we create an IAM role, as we did. And then again define permission policies. And once we're done, we attach the IAM policy to our role. So just some code snippets so that we can appreciate how that is done. So again, Terraform will provide you with a resource to create OpenID Connect provider. So that's what the first resource definition does in this configuration. And we are also going to fetch GitHub's OpenID Connect thumbprint to help us with the token generation. So the token that will generate here will be mapped to our role so that we are able to get, similar to the IAM roles for the service type, we'll get temporary credentials that can be rotated within some given frequency of time. So once that is done, we create the trust policy as mentioned. As you can see, this is of type federated. Up next is to be very specific so that you are not granting access to all repositories within your organization or account on GitHub. So the definition you see here will help you narrow down specific to a given organization, GitHub organization. This could also be your GitHub username or personal account. In addition to that, you'll also specifically select a repository so that it's not all repository that you'd want to track. And lastly, you're also going to pass a branch. And in this case, I'd advise that the branch that you're going to pass in here should be protected so that you have an extra layer of security. So we're going to see this in action and how we're going to pass in the arguments to these parameters. So once you're done, so let's see that in action. I'll head over to my code. So I have my Terraform code defined within modules. So let's take a look at the GitHub or IDC module. So as you can see, this is the code snippet that I showed earlier that creates our identity provider. Here we fetch the thumbprint from GitHub. Over here we define our trust policy and create our IAM role here. Now these are the specific permissions that we grant our CI server. As you can see, my intention is to give administrative access to EC2 resources, and part of the operations that I'll also need my CI server to do is autoscaling operations. And as you can see here, I also will require admin privileges to autoscaling operations. I'll also require the same for elastic load balancing. Now, if you remember the diagram that I showed us here, so we have the S3 bucket, and also for an illustration, we also had DynamoDB. So S3 bucket, as mentioned, is used to store our Terraform state, and DynamoDB to store, to enable locking within the DynamoDB table. So that explains why part of my permissions here includes allowing access, specific access to S3, for listing my bucket, getting the object within my bucket, doing any patch for my object, and deleting my object as necessary. And these operations are performed specifically on resources that strictly I'd want or would wish for my CI server to have access to. So as you can see, I'm parameterizing my S3 bucket and the S3 bucket object, which is a reference to my key that points to my Terraform state. So as you'll also see, part of the configuration that I have is a deployment to Amazon RDS, whereby I'll be creating, actually I've already created a MySQL server DB. So that means that if I need my CI server to have access to the MySQL database, then I'll have to ensure that I've also granted it access to the Terraform state for that particular MySQL database. So that's what I do here. And this is parameterized so that you can pass in your path specification of reference. It could be your primary database, or that could be your replica database. So this is being specific, as you can see. Otherwise, I've given access to a wider scope. So that will mean that expanding the blast radius for my resources. So the same applies to the DynamoDB table. So I give it specific privileges for the table and for the items within that table. And again, the resource that applies to that is also specified here. So that's just about it. So let's see how that works. So let's shift away from our reusable Terraform module and go or head over to our root module that implements this module. So that will be this here. So let's take a look at that. So you can see on line 14 and 15, I'm basically implementing or making use of the module you just saw earlier, and I'm passing in only the allowed repositories and branches. So this is the repo name and this is the branch name. You can see how specific I am. And as mentioned, as much as possible, as part of an additional security layer, ensure that the branch to which you pass or give access your CI server is one that's protected. So these are the variables that are required within my Terraform reusable module configuration. So that's what I pass here, including the name of the role we are creating, the DynamoDB table, the S3 bucket name, the path to a web cluster key, which, as mentioned, is a reference to our Terraform state for our web cluster, and also a reference to the Terraform state for our MySQL database. So only the resources to which you want your CI server have access, that's what you pass. No more, no less. So let's head over to this repository, this GitHub repository, and see what we have as far as the GitHub workflow is concerned. So that's Terra 1, as you can see. So let's look at the GitHub workflow and see what we have. So in this case, we are applying changes to our AWS environment. But since already I'd applied some changes, let me change this so that we'll be destroying the existing infrastructure that had been provisioned earlier. So let me just mention something else. So you can see that we need to pass the specific role that we created. And this is the role that contains constrained privileges, or the least access privileges that we've granted our CI server. Otherwise, if we left this for grabs, then that would mean that we'd end up with a blast radius that is so wide, and risk exposing almost all resources to our CI server, something that you really would want to avoid. Yeah, so you have to ensure that in your GitHub workflow, you're passing the role that you've created earlier based on the module that I showed us a few minutes ago, so that you're only applying the necessary changes to the resources that specifically you've granted your CI server privileges to access. So let's take a look at that. So let's save our changes and head over to apply, make a commit and push that. So let's see the difference that we have. So instead of applying, we're going to destroy. So let's commit our changes, and so we are going to destroy our web cluster. So let's push our changes. So our push event will trigger our GitHub Actions, so that we have, so let's just see, that should be So let's see the latest action that we have. So you can see we had our infrastructure here. Maybe I can just open up so that we have a visual of our console. So as you can see, we have 3 instances running. Let me just take a look at this. Okay. Do we have... Okay, so it looks like the destruction happened so fast. So let's head over to our GitHub Actions page. So it's applying the destroy. It was an auto approve, but I'd caution that instead of doing an auto approve as I did here, you could allow for approvals from one of your team members anytime you'd want to either do an apply or destroy, so that there's an added level of scrutiny. So let's see. Yeah, I think our job ran successfully, and that's why we were not able to see the resources on the console. The destruction happened so fast. Yeah, so I think with that, you've been able to learn how you can implement a secure CI/CD pipeline using Jenkins running on top of EC2, and also OpenID Connect with GitHub Actions. So I'll take in questions, and thank you for listening.